Hello, and welcome to the air conditioning system lesson in the PMDG 737 Next Generation Groundwork from Angle of Attack. This lesson will cover the following topics: air conditioning system overview, air-conditioned air distribution, air conditioning compartments, mixed manifold description, air conditioning packs and airflow control, cooling cycle and water separation, recirculation system, ventilation system, equipment cooling system, and a lesson summary. The air conditioning system is made up of an enormous amount of interfaces and mechanisms that control the interior environment of the 737 NG for passengers, flight crew, and electronic equipment. In this lesson, our discussion is going to cover an explanation of how most of these systems operate and how the flight crew controls them. Essentially, the air conditioning system performs the following functions. It produces fresh conditioned airflow for air pressurization and ventilation, controls the flight compartment and passenger cabin temperatures, recirculates around 50% of the cabin air for ventilation purposes, and removes unpleasant air from lavatories and galleys. For air conditioning purposes, the 737 NG cabin is divided into 3 zones: the flight compartment and flight deck, forward passenger compartment, and aft passenger compartment. Conditioned air may come from either of the following sources: ground-supplied preconditioned air, recirculation system, and air conditioning packs. All sources supply their conditioned air to a main distribution manifold, also known as the mixed manifold. This essentially acts as a giant pool that collects conditioned air from all sources and supplies it to the respective cabin sections that require air conditioning. The air conditioning packs supply cool conditioned air at one specific temperature that's in accordance with the coldest of the 3 cabin zones. Because of this, the other 2 cabin zones may end up being colder than they need to be. To counter this condition, the other 2 cabin zones are precisely fed with warmer air to bring the zone air temperature up to the desired limit. This warm air is known as trim air. We'll talk about all these systems and components progressively, so let's start with the air conditioning distribution system. The air conditioning distribution system is in charge of supplying conditioned air to the 3 airplane zones and to electronic equipment for cooling purposes. The flight deck zone is provided a constant supply of fresh air, and the passenger cabin zones, forward and aft, are provided fresh air and recirculated air. Electronic equipment is cooled with fans that move air around the equipment. Conditioned air from all the sources is mixed and collected within the mixed manifold, as mentioned before. These sources are left and right air conditioning packs, ground-supplied preconditioned air, and the recirculation system. There's also a ventilation system that takes advantage of pressure differences to extract air from the 737 NG's lavatories and galleys. This process is briefly discussed further along in this lesson. The flight deck is supplied with conditioned air from the left air conditioning pack. If the left pack becomes inoperative, the flight deck automatically receives conditioned air from the right pack. Flight deck temperature may be selected differently than the passenger cabin with the control cabin temperature selector that has 2 positions. Automatic. Temperature is automatically controlled. If the selector is rotated towards C or W, which are cool and warm respectively, manual temperature control is engaged. Off. The flight deck trim air valve is closed, and the temperature controls produce air to supply a 24 degrees Celsius demand. Trim air will soon be discussed in this lesson. The forward and aft passenger compartments are supplied with air from the mixed manifold. From the mixed manifold, conditioned air flows through rising ducts and up sidewalls to an overhead distribution duct that effectively distributes air symmetrically in the cabin. The passenger cabin compartment's temperature may also be controlled with the related forward and aft cabin temperature selectors. These have the same positions as the control cabin selectors. All three cabin selectors have a range that is approximately 18 degrees Celsius to 30 degrees Celsius. They are also associated to three zone temp lights that illuminate when there is a forward or aft cabin duct temperature overheat, or there is a control cabin duct temperature overheat, or there's a failure of the flight deck primary and standby temperature controls. The primary and standby temperature controllers are electronic units that control the pack temperature control valves to satisfy the conditioned air demand. There's a primary and a standby controller to provide system redundancy, so if a primary temperature control fails, the standby control assumes authority immediately. When this occurs, the pack light illuminates in the air conditioning panel, and there's also a master caution and an air conditioning system annunciator. If both the primary and standby temperature controls fail for the same pack, the same alerts will display and the pack will still continue to operate, but without any form of temperature control. When the condition that caused the pack light to illuminate has been corrected, the trip reset switch must be pressed in the air conditioning overhead panel to bring the system back to normal operation. Trip reset is also discussed in the bleed air lesson. Now, we've mentioned the word pack a few times already in this lesson. What exactly are the packs? Let's discuss a bit about what they do, how they take warm air, cool it, and deliver it to the mixed manifold. Packs are very ambiguously discussed in the 737NG documentation. However, the word pack is actually an acronym for Pressurization and Air Conditioning Kit. Essentially, the two packs on the 737NG are small air compressors that take bleed air from the engines, after which the air is cooled, filtered, and delivered to the flight deck and forward and aft passenger cabins for temperature control. Bleed air is extensively discussed in the air systems bleed air lesson, but essentially, it's highly compressed, high-temperature, high-pressure air that's extracted from the engine compression stage for pneumatic power. Both packs form part of the cooling process, which performs the following functions. It regulates bleed air demand from the pneumatic manifold towards the air conditioning packs, removes excessive heat from air entering the packs, and controls the temperature and humidity levels of the air that exits the packs. Moving on, bleed air passes through a flow control valve that regulates bleed air flow according to pack demand. The flow valve is controlled by the air conditioning pack switches in the forward overhead panel. There's one switch per engine, and both have the following positions: off, auto, and high. The operation logic is simple. When both packs are operative and their switches are in the auto position, the packs provide airflow under normal conditions. Naturally, if one pack fails, the other pack automatically switches to high airflow to supply the demand for conditioned air and ventilation. This protection mechanism is only available during flight when the trailing edge flaps are in the up position. Similarly, like in the case of a bleeds-off takeoff, where both engine bleed switches are off and the APU is supplying pneumatic power, the packs deliver high airflow regardless of any flight parameter. For a detailed explanation of the bleeds-off takeoff procedure, watch the 737 NGX line work bleeds-off lesson. After the flow control stage, air passes through a heat exchanger where ram air cools down the bleed air. Ram air is external dynamic air that enters the aircraft through a ram air inlet door. When the aircraft is moving slowly, such as during slow flight, low air density, or ground operations, the ram air inlet door opens to its fully open position to maximize air intake. When this occurs, a ram door full open light illuminates in blue color in the forward overhead panel. Under normal circumstances, the door automatically varies between the open and closed position. Once the initial heat exchanging has taken place, air passes through an air cycle machine that compresses, refrigerates, and sends the air to a second heat exchanger that also cools down the compressed air with the use of ram air. Afterwards, compressed cool air passes through either of two water extraction ducts, where water in the airstream is condensed and falls into a sump, where it's then drained. It's important to keep air free from moisture to minimize the risk of icing at low temperatures. All the collected water from the air conditioning pack water extractors is ducted and sprayed into the ram air inlet so that by evaporation, the ram air stream becomes cooler and therefore more efficient in the heat exchange process. Once the air has passed through all these stages, it has already been conditioned, cooled, and is now ready for distribution into the aircraft zones. From the packs to the main distribution, or mixed manifold, a valve opens to allow the conditioned air to flow in that direction. Air from the packs is delivered at one constant, fairly cold temperature. This temperature is mostly unsuitable for the comfort of passengers and flight crew. Therefore, some form of warmer air must be mixed into the conditioned pack air. This warm air is known as trim air because it essentially trims the pack air temperature to make it more comfortable. The trim air pressure is regulated for the flight deck, forward passenger cabin, and aft passenger cabin. It may also be shut off by the trim air switch in the air conditioning panel, which has the following positions. On. The trim air PERSOV, or pressure regulating and shutoff valve, opens, and each individual cabin zone trim air valve is enabled. Off. The trim air PERSOV closed, and each individual cabin zone trim air valve is disabled. Trim air is extracted from the bleed air that passes through the flow control valve we mentioned earlier, and is ducted towards 3 trim air valves, one in each cabin zone. In simple terms, the packs deliver one air temperature according to the coldest cabin zone. Trim air heats up the other 2 cabin zones to increase their temperature to the desired automatic temperature of 24 degrees Celsius. Pilots often wonder, why is warm bleed air cooled by the refrigerators and then mixed again with hot trim air to deliver it to the cabin, as it seems to be an inefficient process? Turns out it's actually easier and more efficient to run the packs by delivering a constant cold output temperature and then adding warm trim air as required to maintain a comfortable cabin temperature. Even modern aircraft, like the Boeing 777, maintain a similar air conditioning architecture. Moving on, air in the flight deck is 100% fresh air from the left air conditioning pack. Air in the passenger forward and aft cabin is a mixture of fresh air from the right air conditioning pack, the mixed manifold, and a certain amount of air that is recirculated within the cabin. We'll now discuss a little bit about the recirculation process and its function. The recirculation system supplies air for ventilation to the passenger cabins by collecting cabin air and mixing it with pack air in the main distribution manifold. The whole recirculation system's objective is to reduce the demand for fresh air from the pneumatic system, or engine bleed system, and from the air conditioning packs, making the process much more efficient. All the recirculated air is pulled through an air filter to remove very small particulates, bacteria, and microorganisms. Recirculation is achieved with a left and a right recirculation fan. These are operated by the pilots with the left and right recirculation fan switches on the air conditioning panel. These switches have the following positions. Off. The recirculation fans are off. Auto. The recirculation fans are controlled automatically. Auto recirculation operation has 2 modes, ground and in-flight. On the ground, the right recirculation fan operates constantly, and if both air conditioning pack switches are high, the left recirculation fan operates too. During flight, the left and right recirculation fans operate while both air conditioning packs are operative. Air from both fans passes through a recirculation fan check valve that prevents any form of leakage or loss of conditioned air back into the mixed manifold from the recirculation system. Moving on, we've seen that recirculation is a fairly straightforward process. Another system we'll briefly talk about is the ventilation system. As we mentioned earlier during this lesson, the ventilation system removes unpleasant air from both the galleys and lavatories in the passenger cabin. By creating a pressure differential, air always flows from where there is high pressure to where there is low pressure, thus creating a form of suction. You may also know this is a vacuum. The ventilation system takes advantage of this principle and ducts all the unpleasant air out of the airplane. During this lesson, we've extensively talked about air conditioning, cooling, ventilation, and recirculation in the three 737NG cabin zones. However, there's another function performed that doesn't really fit the mold of what we've already discussed. Electronic equipment near the flight deck can get very, very hot. Because these systems are important, for example to present data on the flight crew's display units, they must be kept cool and free from the risk of overheating. For this purpose, the air conditioning system also has an equipment cooling system designed to remove heat from the electronic components near both the flight deck and the electronic equipment bay located slightly aft and under the flight deck section. You've probably seen something similar in a PC or laptop, with fans that draw air across the internal components simply to cool it down. Although this system is more complex than that, it's the same general idea. Essentially, the equipment cooling system is simply made up of an air supply system that takes cool air to the electronic equipment, and an air exhaust system that removes the warm air. As a protection mechanism, both the supply and exhaust systems contain two fans respectively, a normal and alternate fan. The related fans are operated with the equipment cooling supply or exhaust switches, located in the forward overhead panel. Both switches have the following positions. Normal supply exhaust fans are operational, and alternate. The alternate supply and exhaust fans have been activated. How does one know when to switch between both fan types for either the supply or exhaust system? The answer is when the off light below each switch illuminates. This light comes on to alert that there is little or no airflow from the selected fan for either supply or exhaust. When the off light comes on for both fans, the airplane electrical systems must be partly shut down to reduce the electric load and therefore bring the equipment temperature down. Together with the off light, a master caution is presented along with the overhead light. The presence of a master caution may surprise you, but keep in mind that if the equipment is left to overheat, it could potentially start a fire on the flight deck. This is one of the worst emergencies that can happen on an airliner, as an incapacitated pilot can't exactly operate the aircraft safely, rendering all courses of action useless. We've had a short but very detailed lesson about the air conditioning system. Even though the system is fairly complex and has a lot of interfaces, it's important for you to understand properly how to operate it. After all, you don't want your sim passengers to feel very hot during your flights on the 737 NGX. This lesson covered the following topics: air conditioning system overview, air-conditioned air distribution, air conditioning compartments, mixed manifold description, air conditioning packs and airflow control, cooling cycle and water separation, recirculation system, ventilation system, equipment cooling system, and a lesson summary. The next lesson will wrap up the air system section by talking about pressurization. Stay tuned. Until then, throttle on.